Hi, I'm taking Paul McWhorter's Raspberry Pi lessons. We're on number 7 and talking about GPIO inputs with button switches. I come from the Arduino side and pretty familiar with buttons and like that. And we were talking about internal pull-ups and pull-downs. So uh, that was a little bit of good information that he had there. One thing that he gave us homework to make a toggle switch for the LED. In other words, you press the button once and it turns the LED on, and you press it again to turn the LED off. Like say I've done that on Arduino, so it came over pretty easy to do the on the Python side. So one thing to note, we got 5 LEDs, but I just have the middle one here tied to pin 13 when we're doing in my code. And also Paul used internal pull-ups on his button switch. And what that does is reverses the logic on it. So when you push the button, it's 0. And when you let the button up, it's 1. That's the way it works on Arduino. They don't have pull downs on our regular Arduinos. So I kind of like the pull down because it keeps your logic in the right direction. When you press it, it goes high. It'd be like turning a switch on. It would, make your high. So I used pull downs on this instead. The difference is that on the pull ups, you would tie the other side of your button to ground. If you're using pull down, then you got to tie the other side of the button to 3.3 volts so that when you complete the circuit, that the pin sees the high voltage. So that's the only difference there. So let's go on to the code. Again, I'm using the VNC to remote into the Raspberry Pi, and we're using this code editor here in Visual Studio Code to do this. So Paul said it wouldn't take too many lines of code to do this. So I said, yeah, well, it should be pretty good. So we're doing the importing the GPIO library and the importing sleep from the time library. We're defining a couple of our pins with names so that we can know what they are. And then because we are actually creating, we need to know the state of the button. We need the current state and the previous state. So I just call them button state and old state. And then just what I use. And we're using BCM because this is the cobbler thing, has the BCM numbers on it. We're setting up our lead pin as an output and our button pin as an input with input pulled down. So that's what that is. We're using the try except so that we can exit cleanly from our program with a control C. And then inside that, we got a while true that we're using to loop through our code until we're ready to quit. So first thing we're doing is reading whatever the input pin is, the button pin, and we're putting that into the button state. So that's either going to be high or low. And then what we're doing is we're doing a double check down here. We want to find out if this is the first time that the loops happen since the button was pressed. We want to check that the current button state is true, but that the last time the loop went through, that the button was false. So we at the end of our loop here, we change the state, the old state, to the button state before we go back to the top. So this allows us to only do this if statement if it's the first time that the Raspberry Pi has seen a high. So you're actually just recording the state change. So that's what that does. And then when we do that, all we're doing is toggling the pin. So I was doing some reading in the documents, and you can, even though it's an output, you can read what the current output of a pin is by doing an input on that pin. And that gives you, so if the pin's already high, this will tell you that this will return high. And we put a knot in it. So all that does is toggle the pin. So if the pin's high, it's going to go to low. If the pin's low, it's going to go to high. And like I said, that's basically all we do. And then this just each time through the loop, it's going to, create an old state, update the old state button as well. And we're just sleeping 0.1 just to slow the program down. And that also takes care of the debounce on the pin. So we don't have to worry about debounce. So, and then when we do the control C, we just do the cleanup. So I think I'm ready to run this. We can see if it's working. All right, so I'm going to press the button and the pin comes on, press it again, goes off. And it doesn't matter how long we hold this. If you wouldn't have had this state in here where you're finding, that it's the first time through, if you held this button down, it would kind of just loop through, and be off and on, off and on. So by doing this, you're only the first time that it's held down, and you have to wait for a release before it's going to check for another state change. So that works fine and everything. And then we're just down here looking for a control C, and we're out of it. So like I said, I've been reading a lot of the documentation, and also from 6 months of following Paul and taking his lessons a little bit farther, I've got a little bit of a handle on this Python thing. And there's some things that we can do in there, and that we can make it easier and shorter code. So I said, well, this is 18 lines of code to get that done and nice and neat. How short can we actually make it? So I got a second one here, and we're actually down to 7 lines of code. So what we're doing, we don't need time anymore, because we're going to let the GPI library take care of that, the timing, the bounce, debouncing for us. So we don't need the time library anymore. And I decided to use the pin numbers, just so I didn't have to use some variables, just to keep it as short as possible. Of course, it doesn't make for the cleaner code, but I just want to see how short I can make it. So we're making 13 the output, which is the LED, and 21 the input with pull down for the input for the button. And then this line here is the magic that works with the that makes it a little bit better for, we're using the GPIO add event detect. So we're putting an event in there, and we're detecting when the GPIO, in this case, we're detecting when it goes from low to high. This rising means it's going from 0 to 1. And when that happens, it's going to create this event, and it's going to do a callback function, and for the that'll actually be in a separate thread. So it's actually in a different thread. So, but it's built in, so we don't have to worry about the threading library or anything like that. And like I said, and then at the end here, it automatically does debouncing, and because it's in a separate thread, it's not going to be blocking or anything. So this is going to be going to let the pin settle for 200 milliseconds before it checks it again. So 0.2 seconds. And normally you would put a function name in here, and you would have to set a function up, but one cool thing with Python, if you only have like a one-line function, you can actually do what they call this lambda function, which is an inline function, where you can actually just do it right in line, and you don't have to worry about defining a function outside. It just does that line of code just like it was a function. So this is the same line of code that we had in the previous version, where it just reads the GPIO pin and sets it to the opposite. So the lead pin is going to be not whatever the lead pin was before. But so that was kind of cool. And like I said, this all happens in a separate thread. So we can actually use this input thing, which is totally blocking, and it'll keep checking on this, because this is like an event type thing, like a interrupt type thing that's going to happen outside of our code here. So we can just sit here and wait for a thing before we clean up, and it'll continue to work. So that was kind of cool that that does that. So we can just show it. It's going to work exactly the same as the other one. So the only thing is like I say, so we're normally this would be blocking and nothing else could happen in our code, but because we have this event detect in here, it's going to let us do the same as we did before. Even though our present code is blocking, the event is in a separate thread. So anyhow, so I've got it done in 7 lines of code with a little bit of the Python magic that we can do with the libraries and some of the internal workings of Python. So that's my homework for this week. Thanks, Paul, for all you do. I keep learning from you, and you make me want to go learn more. Talk to y'all later.